Good evening from Osaka. 皆さん、こんばんは。My name is Antti Kunnas. I'm the Executive Director for the Finnish Chamber of Commerce in Japan, and I'll be moderating the panel discussion this evening, where we will discuss on Finnish digital expertise. 皆さん、こんばんは。はじめまして。私、在日フィンランド商工会議所で専務理事を務めてます、アンティ・コンナスと申します。本日のパネルディスカッションの司会を務めさせていただきます。よろしくお願いいたします。So we have a big theme tonight. We are talking about the digital transformation, especially how we, as our home country, which we all here today represent, how we can bring Finnish digital solutions to solve global issues, and what type of good experiences we have had in Finland. The theme, digital field and digital transformation, is extremely wide. So obviously we cannot cover everything in just 1 hour, but we hope that we will raise some good thoughts and maybe some ideas which will guide the future solutions and better society and future. First of all, I would like to ask the participants to give a short introduction, your names and your organization, and what you work on. Janne.
Yes, my name is Janne Järvinen. I come from Business Finland. It's a government agency that provides innovation funding, trade, travel, and investment promotion, and also talent attraction to Finland. I'm the mission lead for digitalization. We see that digitalization is one key field where there's a lot new opportunities to gain, and I try to guide our troops in coordinating our activities on that side. I'm very happy to be here tonight.
Hello everybody, my name is Mikko Välimäki. I'm co-CEO of IQM Quantum Computers. Our company builds and delivers quantum computers worldwide. We are the biggest company of all the quantum component manufacturers in Europe today, and we have already built more than 30 computers total. And out of those 30, 10 we have delivered to customers worldwide. We have multiple installations already in Europe, and also we have started now the business in Asia Pacific. We have the first computers in Korea and Taiwan, and looking forward also the Japanese market at the moment.
Well, good afternoon, or is it evening already? My name is Ari Pouttu. I'm a professor at the University of Oulu. I'm also Vice Director of 6G flagship at our university. It is the first 6G research program in the world. We started 2018 when most of our collaborating partners started in 2020. So we have been there already 7 years, and actually we are now looking what comes after 6G. So that's my role as a research player in this cellular world. Thank you.
Good afternoon. My name is Mika Rantakokko, and I'm working as connectivity lead in VTT Technical Research Center of Finland. VTT is working as a research organization developing advanced connectivity solutions for different purposes. VTT is working as applied research institution to support companies to exploit the opportunities what digitalization can bring to the companies and also to the societies.
Thank you all speakers on your self-introductions, and as you can hear, we have quite a variety of backgrounds and top-level research and corporate solutions in the digital sector with already in place applications which are extremely interesting to hear more about and to see where we can take the discussion towards. First of all, I would like to ask Janne, you overall, how would you describe the Finnish digital field? How has it come together and how does it look currently? How is it different from other countries?
Finland has been always at the top of the digital rankings in the world, so I would say that we are fairly well developed there. We are a small country, so it's perhaps easier to put together infrastructure and also collaboration when it comes to digitalization. But still, I would say that there are a number of challenges as digitalization has changed over the years. Before, it used to be that the digital matters were only part of the IT department, and many of us didn't have the cell phones that we have today. But now I think digital permeates all our lives, whether we are there in person or working in an organization or company. So digital is much more central to our lives these days.
Thank you. What about you, Mikko? You explained us briefly on your company and what you are doing. How would you say that for those who are not familiar with quantum computers, how has the past 5 years been and how does the next 5 years look?
Thanks for the question. So quantum computing is actually a new technology and a new market. And we are in a privileged position in the market with IQM quantum computers because we are one of the market leaders. So this market really didn't, I would say, even exist over 5 years ago. And Finland actually has been in the forefront of quantum market creation over the past 5 years. Just 1 month ago, the Finnish government published a quantum strategy. So it's a government initiative and one of the strategic investment areas for whole Finland. And today we actually have in Finland, I would call, a very vibrant ecosystem of companies working on different parts, both on the hardware side and then also on the software side of quantum technologies. We also have strong research in various universities, and the government VTT Research Institution Research Center has also been developing these technologies. So it's been quite a boom, especially in Finland, for quantum technologies over the past 5 years.
Also, as there might be many who don't know what quantum computer does, could you easily explain how it is different from a normal computer?
Yes, so quantum computer is a little bit different than normal computer. And actually, it may give you an idea that we have so far only sold 10 systems and installed to customer. And actually, this is the most that any company in the market has done so far. So quantum computers solve a little bit different solutions than traditional computers. They are bigger systems, but they can do amazing things. Maybe the most popular example is that if everything works as we predict, quantum computers can break most common encryption methods in the next 5 years or so, and also all the bitcoins today will be one day stolen, unless you change your encryption to post-quantum methods.
So it's something that has actually developed, or the field has developed quite rapidly, and is something that we should be keeping our look on, I think.
Actually, this research and all the background, the physics of quantum computing is well known and already researched for, I would say, 50 years. So the science here is not new at all. But what has happened over the past 5 years is that finally we are able, from engineering perspective, to build these quantum computers and now develop them further so they can actually start solving the problems that professors in universities in physics and mathematics departments have been already researching for many, many years.
That's an interesting field, and I have many questions still in my mind. But before those, let me go to Ari. you are a vice director at 6G flagship, and I think that many, when they hear 6G, they think about 3G, 4G, 5G. But what is 6G and how is it different?
That's more than an excellent question. Actually, nobody knows what 6G is. The standardization started 2 months ago, so we are now about to standardize what 6G eventually will be. But we know certain things about 6G. It's a bit better than 5G in terms of data rates. It's better in terms of providing communication between computers, so it's faster in terms of delivering data. It's going to be a sensing instrument, so it can sense the environment simultaneously as it's transmitting the radio signals. So it is a sensor. It's a sensor of the world, if you like. The third thing that is obvious is that we will have computing everywhere in the network. That means introduction of this artificial intelligence to nodes everywhere in the network. That provides us excellent tools for the next generation of any service to be provided by telecommunication infrastructure to industries, to hospitals, stadiums. So these private networks are going to be part of the equation, complementing what we now know as mobile network operators, which operate nationwide. And so these private networks, which are providing local services for certain players, will also be part of the storyline. So it's a marriage of sensing, communication, AI, and in the future we have seen some developments in the world politics that what needs to be also tackled is that instead of what we nowadays have, for instance in 5G, the best effort practices will be transferred to resilient by design type of solutions, where we really take a good look at how do we make these systems as much withstanding natural disasters, cyber attacks, or even intentional interference.
And I think that you also collaborate with Japanese counterparties with the 6G flagship.
Yes, we do. We, for instance, currently are running 2 large projects, one in Finland, one in Japan, which are basically following the same research plan. Together with Professor Akihiro Nakao from Tokyo University, we are having this project, which is looking at these democratizing communications, so 6G and private networks, and how those can be served, be serving the future of the different verticals.
Good. I think that there's a lot already going on, and much more to still be.
So we hope.
In the future. Yes. Mika, what about you? I think that for many, when you say connectivity, some have a clear idea what it is, and some might not be that familiar. But how would you say or define connectivity, and to all, what type of matters is it linked?
Well, indeed, when talking about connectivity, it has been so far that we are talking about mobile phones, and yeah, we are doing everything with mobile phone. But now connectivity is and will be more when going forward with future technologies. It will be the enabler for everything. So when we are talking about connectivity of machinery, when we are talking about artificial intelligence, it's also enabler for artificial intelligence. So it's really enabler for all the digitalization as such.
So you could say that it is something that the digitalization cannot actually take place without.
Well, indeed, when we are talking about the basic infrastructures, we are talking about electricity, we are talking about water. I would like to add to this line also connectivity.
That is something that I think that gives a lot of thought and needs to be taken quite seriously. Seriously, I believe. I think Jan has a comment on that.
Yes, we recently looked into how are the new startups different than traditional companies, so that new companies can start from like a clean table, and it's easier for them to work in a digitalized world. But what we found is that connectivity is one piece of this equation, that you have very good connectivity, but that's not everything. That in order to be this what we call a digital native organization, you need to have like a connectivity, plus you need to have like this data always available, and when you connect this to the computing power and put these three together, then this is a very powerful combination that can help you to achieve a lot of things through digitalization. And we urge that all organizations urge to go to be more digitally native, at least in their thinking inside the company. Even though you are a traditional company, we all believe that you can get better at this.
So you mentioned there some like how startups, for example, approach this. How would you describe the Finnish companies or Finland as a society overall in this aspect? Where is it headed?
Yes, I think that in Finland we have very many companies that are in the lead in this digitalization, and they are already taking benefits out of that. But also I believe that there's a lot of room for improvement for different kinds of companies. That I think that in many countries there are like established companies who have worked for a long time, and for those it's not so easy to think that how can this digital help me. But we have found that even for a very traditional company, it's beneficial to invest in digitalization. For example, Finnish children's clothes manufacturer Reima, that has been working for over 50 years, they made a decision that they invest in digitalization in a big way, and as a result, they managed to succeed in the USA market that's extremely competitive, and without digitalization they could not do this. But now it's their top selling country. So I believe that all companies can get better at this, and as the world is changing, like Mika was telling about the AI and all that, that's a reason that we are all in this continuous development that we all need to kind of like at least consider in our organizations.
Mikko, how about regarding quantum computers? As it's still quite a difficult question for many. What has been the issue until now? Has it been accessible for people and companies, and how will the future in that aspect look?
Right, so one of the challenges in quantum computing specifically, we talked about startups here a little bit, and actually most of the companies worldwide who are building quantum computers today are new companies. They started as startups in the past 10 years, and now many of them are bigger companies like our company, more like a scale-up. Really the problem has been that there hasn't been enough computers available, and how at least we have been thinking about that problem is that we want to provide as open and transparent platform as possible at the price point which is accessible for, let's say, public organizations like universities who want their students to start working on quantum computers as soon as possible. And I think this plan has kind of worked out pretty well. But yes, that has been one of the main problems of quantum computers, that they have been studied, and quantum computing has been studied for tens of years at theoretical level. Professors have worked in their classrooms and with their simulation models. and there hasn't been real quantum computers available. But that has now completely changed over the past, I would say, 5 years, and we are now entering a new era where you will start to hear about quantum computers from popular news media, TV, newspapers, and I believe this will just continue. Just like in traditional computing, when I grew up back in the day, all the computers were based on the so-called CPU architecture. There were microprocessors inside, and companies like Intel were very popular, and people talk about what they do. It was Intel inside always. And now recently, these GPUs came up, and now everybody's talking about NVIDIA, which is it now the highest valued company in the whole world. They became somehow super successful because there was AI boom, which was basically these GPUs NVIDIA was doing. They actually enabled the AI boom. Without NVIDIA, there would not be AI boom. Something similar would absolutely happen with quantum computing. We actually don't know what the killer application is, but these technologies, these quantum processing units, we call them QPUs, are out there already, and it's about time we see the next big IT revolution coming from quantum.
I think that you mentioned there that until now it's been more like a simulation level, not having the actual computer, and it has been mainly university professors and researchers doing the work on the calculations and all. But now, when there is starting to be more and more actual computers, is it that we are seeing that the companies can now have one or access one, or the students can try something, some new ideas on the computer, or how does it actually work?
So absolutely, in the long term, we believe quantum computers will be just like normal computers, like I mentioned, your phones or laptops which have a CPU inside, or like your graphics card which has a GPU inside. You will get access to a quantum computer as well. And programming quantum computers in the future, we believe, will be as easy as today somebody's writing the most popular programming language, which is, I guess, Python these days. So as simple as writing Python code. We are not there yet, but I think this is the goal, and this is where the world is heading towards. So quantum computing will be taught in universities for any student who learns today programming. Of course, you need certain level of technical knowledge and interest in dealing with computers, but if you're working with computers today, or you want to study computer programming, or in general something about IT, I believe quantum computing will be kind of mandatory subject in the very near future. And actually in some universities in Europe, it already is.
I wish I would be a little bit younger. I guess I could even now start it as a hobby to learn more, but that sounds exciting in many ways. But I think that 6G doesn't lose that much in the excitingness, because it will also be quite an enabler in many ways. Regarding, we have also been discussing with the digitalization also resilience and security, but what type of part will 6G play in that mix, in the resilience of digitalization?
I think I mentioned earlier that 5G was built on best effort design, and now we are planning that 6G should be built on resilient by design principle. So it means that we look through all the possibilities that we have in the system and figure out the better way to do it so that it can withstand on systemic level as well as on radio link level these unintended or intended interferences into the system. In the short term, for instance, we could ask for operators to provide national roaming for catastrophic situations. So it could be mandatory that when there is a disaster, all networks are open to all customers. That is a very simple way to start building the resilience in our networks. So if one operator loses its base station in a certain region, there might be another one which is operating still, which was not hit by something. And then going through all the different protocol stacks in the system, we will then start looking at more resilient ways to make this system operate so that if these things happen, they are more likely to stay alive. And for instance, one example in Finland is that since these 5G systems rely on GPS, so satellite navigation system, for timing, so this timing is very important in 5G because all the base stations and all the UEs need to transmit at a certain time. And if we don't calibrate that timing over the time, the time starts to slide, and then we start to have colliding transmissions, which means that the system becomes inoperable. And our big neighbor to the east from Finland, if you know what I mean, has introduced some intentional jamming, for instance, for GPS signals, which has already affected on air traffic, but also it has provided some problems with our 5G networks. So yes, we need to look at how do we build this system that they can withstand unknown approaches, unknown ways to cause harm. And why it's so important is the fact that all of our services will soon be digitalized. And if we cannot access them, you know what happens? Turmoil.
Mika, in VTT's work, how is the resilience looked upon, or what type of approach or point of view does it give you in your research and in your field, in the connectivity?
Concerning resilience, of course, we are working with the technology development, which is, of course, essential, so that the technology as an enabler improves, and it is something which provides solution which can be used in different verticals. In addition to that, of course, we are also working very closely with different verticals, that is to say, the users who are using the connectivity. So we can then take into account different challenges, different requirements coming from different users, so that these needs can be met, and then we can really develop and help our company collaborators to develop solutions which are resilient. And in addition to this, of course, we are then talking about technological challenges. As I was mentioning, AI. AI means a lot of opportunities, a lot of good things, how we can develop, for example, networks, how we can optimize the network. But at the same time, we are providing our expertise so that it is possible for our collaborators to tackle also the negative effects of AI. So, for example, how it would be possible to prepare better for these challenging situations when AI is used for something not so nice. There we come into this question about cybersecurity. So that means that we are very much working on secure connectivity so that we really can provide the solution which is functional, it's resilient, and it's safe, and it's also something which ensures that single persons, citizens, companies, and their privacy is protected.
And I think that you mentioned citizens there, and I think that we are talking about digitalization, and at times it might be forgotten that when we talk about that digitalization, it's actually a human-centric field, and human is in the center. We are looking for solutions for the society and for citizens, but it doesn't remove human from the equation, but actually it brings it more to the center. However, at the same time, both Finland, both Japan, many other countries also are struggling of declining population, and there's an expectation that some of the problems can be solved by using new digital solutions. Janne, could you give some examples how Finland is tackling this problem? Is Finland taking this into account in the education somehow in Finland, or is it part of the education system at all, how to think on digitalization?
Yes, I think this is an issue that both Finland and Japan are tackling, and I think in many ways, I at least we in Finland admire what you are doing in Japan in terms of, for example, robotics development and so on. So we have a lot to learn there. But I think that in the future we need to see digitalization as helping our people and helping our society to manage in this new situation. For example, with healthcare being provided in a remote way, or more advanced sensoring systems to tell you what your health situation is and so forth. So, but we also, of course, need the humans, the people who are in the middle of this and can manage this. So AI alone is not the answer, but there always needs to be a human in the center, like you said, and at least we are working so that we want these new systems to be better for the citizens, and so they can be easier, simpler, and also provide the value for their daily life in practice. But all this needs, I think it needs good collaboration and even internationally. So I would welcome collaboration between Finland and Japan on these topics, because I think we share both the problems, but also some of the answers there. So
I think that even though there are many challenges, I think that we have already good ideas how to tackle it and how to take it forward. How about Mikko? There are many things that we can solve with the quantum computing, or the quantum computing can provide a path to solution in many ways. Even if you are not, let's say, specializing in the quantum computing field, what type of education would you normally start with if you want to learn more about quantum computing? So you mentioned normal computers, but is it more actually building the computer itself or the software for the computer?
Well, the quantum computing kind of revolution started really from hardware development, and most companies and researchers and university professors really have been focusing on these qubits. Qubits are the units that are in the quantum processors. But I would say the last few years, focus has started to see towards software and actually developing quantum software and algorithms that can be run on these quantum chips with those qubits in those chips. But you were asking about what kind of capabilities are needed, or what should you basically study if you want to work with quantum computing. And I think here the answer is not that different to any other field of technology. If you want to work for traditional IT company, when they grow up and become more established, and I'm telling you that quantum companies like ourselves is actually getting more established. We are no longer a small startup. We need expertise in all fields of business. We need people who can do sales, marketing, administrative company affairs. At the user side, there are people who analyze the market, who study many other things that not just the quantum computing itself. We need people who run these ecosystems, and we need multiple suppliers when we build quantum computers. We actually need even traditional computing hardware as part of the quantum computer. We also need traditional software. One part of quantum computer is a traditional PC and traditional software as well. That's the way you access a quantum computer. You actually access it with your laptop. Then you connect to the computer. So actually the answer is that from, let's say, the human skill set perspective, this may not be fundamentally that revolutionary. Yes, we need those quantum experts who work on this particular technology and develop quantum algorithms and work on these quantum processors, but beyond that, it's really something that, people have been already trained themselves for.
Maybe I would like to add here that at least at Business Finland, we are seeing among our customers that many of them are like studying the field of quantum computing from their business point of view. So they want to understand what kind of business problems they can solve with a quantum computer, and it's a little bit different than in a traditional way. So many of them are looking into, okay, how can I apply this in like if I'm a medical company, or how can I apply this if I'm a financial institution? So at least I think that you need to kind of like understand that what can quantum computing do for you and for your business, and then you can move forward with finding solutions.
And with human being a big part of the function, there's also a question nowadays, or has been for the past few years, even though human is in the center, what type of change will the artificial intelligence, the AI, bring to this equation? How would you, Ari, see in the 6G field, how is the AI playing out? Is it advancing rapidly, the development, or is it bringing out some new challenges?
Well, in practice, both. One thing that we must remember with wireless systems, they are extremely dynamic. They are random, or the other word for that, it is stochastic, which means that the traditional AI algorithms that we have been using for big data crunching in these big data centers, which is static, it stays there, and you can store it for years and then start crunching. Now we go into wireless dynamic system where the data has life expectancy, sometimes even milliseconds, and it's obsolete. So what we need to have is different type of AI computing in wireless networks that are fast enough to track the problems in real time, which is not the case in many other AI applications. So that's one of the things that's different. But when this problem, and it's partially solved, there are already some solutions available how to use AI in wireless networks. Part of the data is sufficiently slow that we can apply existing algorithms, tweak them a bit, and then get them running. Some of them are still unsolvable, but they will be solved. As for, if you take an extreme, let's say, thought jump, leap of faith kind of thing, the biggest idea nowadays is that we can generate an AI engine, which is the base station, and which is the user equipment, the mobile phone, and there's nothing else. These AI engines talk to each other and then decide what is the most efficient way to communicate data between the base station and the network, and obviously the user equipment. So there are a lot of new things that become possible when we introduce these really real-time AI computing capabilities into our networks. But then there is obviously the other side of things, these applications which serve a certain purpose, not necessarily optimize the network, and those are more easily and readily available from the existing AI world. For instance, robotic control, collaborative robots, or self-driving cars. Many of these kind of applications can be deployed with current technology. Most of the time, the problem are regulation and legislation.
So an ecosystemic question in a way, how to actually build the basis for the future and how to use AI there.
Yeah, that's it.
Mika, how about you? You also, your field of specialization also has AI directly in it, AI and digital resilience. What type of role do you see AI playing in your field and especially going 5-10 years to the future?
Well, of course, first of all, the fact is that we don't know what AI is, for example, in a year. We do know what it is now, but in a year's time, the development will be so fast that it's very hard to predict what's it going to be. But as a tool, we have seen that AI is very useful, and it is something which will be integrated to all the other aspects of our digitalization. This means that there are both positive and negative sides. If thinking about the positive sides, of course, we can really use AI to produce better products. We can use AI to scale the solutions which can be used by our people. But then at the same time we have to be very cautious with AI, because it can also be used for negative things, like it can be produced for developing tools for cyber attacks, or it can be used for false information. So that means we really have to follow this development very closely, and we also have to be very cautious about having the control of AI in our own hands, so that we can really make best out of it without endangering our future.
There's also there between the lines one of the big topics, the ethics of the AI and the development, and I think that is something that is discussed in quite many countries and looked quite critically upon, I think.
Oh yes, and when talking about AI, one essential part of AI is that it is as good as the data where it gets its where are the data sources. So we need to provide the correct data so that AI will provide right information. And at the same time, again, when talking about people, we really have to be sure that we have the anonymization of data, so that single people and their privacy won't get anyhow harmed by AI and AI solutions.
Janne, you have a comment there.
Yes, I do agree that we need to be very, very careful and think about this what negative things can happen. But I also feel that it's good to be thinking positive here, and I think from a human perspective. So, for example, I have used this type of example that in a few years I would like to drive my self-driving cars from Helsinki, my hometown, to Tampere, which is a close by city, and the AI would understand what do I want and what do I need, so it kind of like knows me, and then when I'm driving to Tampere, it says that, hey, why don't we go to this restaurant that has your favorite food as lunch there, and while we are there it says that, hey, I saw that there's a advertisement for this new tennis racket that you like, why can I buy it for you on the special, and they deliver directly to the car. So in this way I hope that the AI helps the products and services to help make our lives easier and smoother, so that we don't know that it's not a burden for us. I mean, I would be happy just that if the AI would help me to tick the boxes that I usually have to tick to not to see some extra stuff or things like this. So I think it can start in a very easy way, but I do see also that the trust is essential, that we don't let the AI run amok.
And as we have heard in all of these questions and areas, these are not something that only one or two countries are tackling, but these are global issues. And one thing that I feel that we should discuss here is that how can we solve all these global issues based on the good experience that we have learned from Finland. One statistic that Finland is nowadays quite famous for, both in Japan and globally, is that Finland has been ranked the happiest nation in the whole world for several years in a row now, and there are of course several reasons. Part is the overall trust in the society. a good collaboration between different parties, between the public sector and the individual companies, and high level of education. And I think that there's also overall something that the digitalization is bringing there to the mix and to the happiness of the smoothness of everyday life. But how do you feel, if we go in order from Janne, how do you feel, what are some good practices that Finland could provide to the world to solve the global issues? How to tackle maybe some new problems with digitalization, or some other practices that are in this field that are really peculiar for Finland?
Yeah, I think that what has as the world events has changed in recent weeks and months, what has been a little bit overlooked is that I think in Finland there's a big tendency in the companies to really solve these big problems like how do we live in peace together with our planet, and I just the other week talked to the Wärtsilä, who's like a big engine manufacturer in Finland, and they say their primary goal of the company is to become carbon neutral. So I thought that wow, this type of big goals are more than just that. Okay, we get more market share and more money. But I think that many big companies are really making a lot of effort in the sustainability side and seeing how digitalization can help them to solve these problems. And I think that's what we need.
Yeah, if I can continue there on the kind of strengths of the Finnish economy and especially the Finnish technology industries, where I'm more familiar with, be it now AI or networking or digitalization in general, or let's say quantum especially. I think key advantage of Finland and Finnish companies is that as we come from a small country, we can't do everything ourselves, and we usually are very open to collaboration. We're also very pragmatic. We don't go to extremes, and we have no means to start trade wars or anything like that. So also working with Finnish companies is kind of typically long-term, very much partnership-based. It's very trusted relationship what we can build with whoever we partner with, wherever in the world that happens. And Finnish companies have tradition and have history to work with many other countries and many other partners across the world. We have been able to work in also many kind of difficult and politically difficult parts of the world in the past. Finland has traditionally been seen as also politically easy to work with if there's politics at play in business in the first place, and these days it seems to be that this is the case. So also in that sense, I think working with Finnish companies is a solid choice. And in general, Finland is known as one of the most advanced societies with very high level of technological competencies, no matter which field we are talking about.
There was a key word there, I think, that has been mentioned already before, and that's collaboration. I think that, of course, when you create something new, co-creation is an important thing. Joint research is one thing also, and I think many Finnish organizations and companies wish to collaborate with the like-minded countries and organizations. How is it with the 6G development? Is that also visible there?
Yes, for sure. Finland, among, was it like 10 other countries, have signed a treaty of developing for dual use purpose 6G technologies only with the like-minded countries and like-minded companies. And Japan was one of those countries, including Finland, US, and some others. No, so it's definitely there. But coming back to the, saving the world kind of thing, one of the big themes I believe, is one of the SDGs, the information availability to all, meaning that we need to build ubiquitous 6G networks so that the 3-point-something billion people who are still not connected to the internet become democratized in terms of getting information. And that will change a lot of things pretty fast in the future in terms of pollution and many things when people start to have education and access to information. So this is a vital problem to solve, and Japan, Finland being one of the ICT pioneers in the world can help here building technologies that connect the remote and connect the poor. So those need to be done.
How would you, Mika, fix the world and solve the issues? What do you think that is something that we could maybe learn from the Finnish society and the ecosystems, which would benefit if we look the digital solutions to serve issues in the whole world? There was a good point from Ari regarding the SDGs, but how would you see what is something that we, as the country, as the Finland and the Finnish solutions, can help solve the issues of the world?
Indeed, Sustainable Development Goals is a good starting point for this, because there are a lot of topics listed which need improvement. And in many of those topics, digitalization can help. So definitely this is something where there's a lot of expertise in Finland, but at the same time, the collaboration with other countries is essential, because definitely it's very good that we have different approaches which we can combine to develop the solutions which works for everybody. And also, if thinking about this current situation in different countries, there are a lot of things which we are doing at the moment, not so sufficiently using a lot of energy. Well, I think one very good example is how we are using banks nowadays. Before, it used to be so that we went to banks and then we were queuing up there, and now hardly anyone goes. It's like years ago when I was last time in the bank. So this kind of approach, using digitalization as a solution which would make lives easier, which would save time, which would save money, is something where our connectivity expertise combined with the expertise in different verticals to really make these end users aware of how things could be done differently. If and when we can collaborate to find this kind of solutions, like revolutionizing banking, I think there we would have a lot to do and a lot to collaborate with.
So technically, digitalization could be seen as a problem solver in practically any field in the world. I think that the potential is still, even though we have had now several years of different digital solutions taking place and taking the world to a better direction, there is still much more room for improvement in many ways. Now I would like to ask if there's someone in the audience who would like to ask questions from the panelists. We have a mic available, and if you would like to ask a question, we can bring the mic to you, and you can ask the question either in English or Japanese. But if there's anyone, please do raise your hand and we will bring the mic to you. Yes, just a moment.
Hi, my name is Levi. I'm only 20 years old, so I grew up at a time where digitalization has kind of always been around, and I think when talking about people from my generation, it's a really big impact in why perhaps there's a lot of difference between my generation and older people. With all these technologies improving, do you see children now and people in the future facing different challenges in the way they communicate, and will their future be different because of all of these new technologies?
I would say yes. First of all, the mobile phones of today will probably be used by the older generation until they die. But the youngsters will start eventually using these wearables, which will then translate into a total new ways of consumption of data, which basically provides you 3D worlds, metaverses. You can travel in the world while you are, doing something else. So the way of consuming the data will be totally transferred into 3D worlds, and hopefully somewhere down the road to photorealistic view of the world. That's one thing that I believe at least will happen in terms of how to consume the data. For us old farts, we will go with our new technologies with the same old habits as we have done so far.
And I think that one question, and you already mentioned there, the usage of data, and that's one thing that even nowadays, like for example, with using the smartphones and how it affects different age groups and generations and their development, for example, from early age, there's still a lack of data, and we still are in the process of actually bringing AI to actually analyze the data and get more results. What type of effects these different new solutions have on at different stages of humans. So
yeah, I believe so. That's one of the things. But as you said, there is not sufficient data to make very strong, let's say, statements on how this will affect. For instance, in Finland, we have seen that youngsters move less than they did 20 years ago because of they don't have to. You have the connectivity device. You can connect with your friends without going and visit him. And these kind of things obviously will have some effect in the future. And I believe the time to start to study these kind of things, how the digitalization will change. I mean, it's part of evolution in a sense. How do we cope with the changing environment? So I don't know what it means in terms of thousands of years, but some kind of habitual change will happen in the next tens of years. So, in your lifetime.
Well, and indeed, when thinking about this current digital services, I think we have to update them. Like, if you think about the current, like some public authorities' website or service there, so, well, if you think about how to access it, I'm sure you might have some ideas how to make them look totally different than the current ones. And of course, this kind of change of how to provide the services, how to develop the user interface for the current services, that's needed and that's inevitable.
And that's your generation's work.
Thank you.
And that's business opportunity for you.
good, thank you, Mika and Ari. Any other questions? Yes, there.
Hello. Thank you for the discussion. In this new world, I think the key is the encryption, because without encryption, we cannot, let's say, have privacy. So, what are you thinking? Quantum computers is going to be to fit in a device like this in the future?
From user's perspective, I think it doesn't kind of matter, because if you are using quantum computer over the cloud, which you are most likely going to use, you can actually use it with your phone today. Did you know that? Here's the thing about technology. We sometimes underestimate the change, and we don't even know what happens in the future. We talked about, you mentioned what is technology today for the previous speaker about the question how you have kind of grown up using these devices. You could say the last 20 years has been maybe the age of the screen. Everybody had phones with screens, but just 20 years ago, nobody had those. They just came suddenly with iPhone and Android. They came less than 20 years ago, actually. What happens in the next 5 to 10 years, we are assuming this will be like this forever. We will keep on watching these screens, and they come with some negative effects as well. Some of the kids are kind of having mental problems and so on. What if this all changes? There can be a new way of using communication devices. The latest we are hearing about these AI companies are thinking about devices with no screen at all. It may sound kind of, we can't even think about that, but you'll see. I'm a technology optimist myself. Quantum computers will be used with your phone or with your AI little ring or whatever tag you have here in the very near future.
So, but in a sense, what you mentioned before applies here, is that even nowadays, if you have one quantum computer, you will need a normal laptop to access and use it. So, but basically, if you have the application running on cloud, you can access it with your cell phone. So it's basically the same principle.
Absolutely. So it's already here.
Thank you.
Thank you for the question. Any other questions from the audience? Yes.
Hi, my name is Masa. Thank you for the discussion. I learned a lot of things from what you discussed about. And then I haven't had any chance to talk to Finnish people in my life so far, so it's a happy too. So my question is a very simple question. What is the main energy in a country? In Japan, we still have 70% of energies come from the thermal power generation. So it's as you know, because giving a lot of CO2, and then one of the guys mentioned about SDGs or something like that. So it's AI and using artificial AI. So using a lot of the energy, you need a lot of energy resources. For example, the Germany stop using the nuclear power, and then now they are in trouble. They are getting the power from the France or something like that. So simply, what is your main power energy in your country? And then, so what do you think about in the future about the energy? What is the change? How we can change it?
I would like to answer that very quickly. So first, about your factual question, you're asking about how Finland is generating energy and electricity and stuff like that today. I think we have a mixed kind of system. There's nuclear, there's a lot of these renewables. We have also water power, but I mean the renewables are growing really fast. There's wind power, and also I believe we have solar power also in Finland applied today, especially individuals can generate power like that. But then you mentioned these data centers and the huge increase in power consumption, which is totally true. And you look at all the trends, that means that we will actually run out of energy in this world if this trend continues. Right now, all the data centers are eating so much energy. If you build a new data center, which is happening almost on a daily basis somewhere on the planet Earth, you always kind of need one power plant pretty much to run a modern data center. But this doesn't have to be like that in the future. Okay, we are building quantum computers, and the most powerful quantum computer today, which can actually solve already such calculations that not even the most powerful supercomputer cannot. The quantum computer only needs a regular plug, what you use to charge your electric or hybrid car to power up. It's calculated depending on the use case that quantum computers use 1,000 times or even less energy than traditional computers. So this can also affect our future predictions. If the computing paradigm changes, then the energy consumption profiles also completely will change.
Janne, if you'd like to continue.
Yes, I do agree that quantum computers have this energy advantage, but at the same time, I do believe that the engineers will come up with more energy efficient solutions. Like Ari was mentioning, energy efficiency is one of the design goals of 6G already. So it's really much on the engineers' table to reduce the power consumption. And I have witnessed in first hand when I was running R&D for a company like F-Secure that if you let engineers use up resources, they will use them all if there are no restrictions. But once there will be restrictions, then they will come up with clever ways to optimize the system. And I do believe that this will happen. And I think that in the AI we already saw one part of that when the Chinese model was much more energy efficient than the other models. So I think that in terms of AI development, we will see that the new models will be more energy efficient, or there will be new ways to improve that. But it's still an issue. But I'm hopeful that we have not seen the latest of that, and in practice I think that we will need both quantum and the regular computers for at least during my lifetime. So we will need to find ways in both sides that we will be more efficient. And lastly, I think that today much of the, for example, internet traffic is people watching cat videos and things like this. So we can think about, okay, where do we have these cat videos? Are they always that they need to be fetched from far away, or can they be somewhere close by so that the energy consumption is not so great? So there are a bunch of ways to improve the energy efficiency, I think.
Yeah, I will give you one small example which relates very well to your life. You receive an email, and the email has, 30 recipients, right? And then what do? When you want to give an answer, you push the reply button. And all the shit that was there before your email is coming with the email, and you send it again. 90% of the traffic is repeating what has always been there. So we are consuming 90% of the resources just by sending same information over and over and over and over and again. Then coming back, so my suggestion is, let's remove the reply button from the browsers in the mail software in the world. Another example of this, how engineering can help, this obviously is not something that could work in a very hot country, but for instance in Finland, we have this high-performance computing center in a city called Kajaani. One of those which consume huge amounts of energy. But most of the energy is transferred, first of all, into computing and then heat. Now, what do we do with the heat? We heat through district heating system half of the city of Kajaani. So all the waste energy is used to heat up the cities in wintertime. So you can come up with this new kind of thinking in using the extra energy that is not being transferred into, let's say, useful format in the first phase, then you can have these secondary, let's say, usages.
And one aspect perhaps might also be that when using AI and developing new AI solutions which require the computing power, then being a little bit optimistic here, but I think that some of these AI solutions, at least, they replace something which consumes even more energy. So in that sense, there could be also that kind of savings in this new system, so that it's not just adding on, but replacing something else and even reducing some of the traditional energy consumption.
I have an example of this one. I heard or saw it in a documentary from Australia. Australia is having a lot of different kind of mines. They have gold mines, they have iron mines, they have a huge number of mines. And by using AI and really good logistics algorithms, they could reduce the number of driving with vehicles so much that it was worth 100 billion Australian dollars in a year, just by using AI and optimizing the mine logistic, how much they drive with the cars and how much they excavate and that kind of things. So 1 billion Australian dollars in a year, just by optimizing with AI algorithms.
And it's a fact that we do use, the whole world uses a lot of energy currently, and one important word that we haven't really mentioned during this evening, partly for the reason that it's overused today, is the word innovation. To tackle these big issues, we don't need just product development, but we need actual new innovations to go to a different level. Quantum computing is a good example that the computer is, if not rethought, it's taking it to a different level, and it's actually an innovation as it's something already different. With the energy also, there are some new energy formats coming together. There's a lot of investments into new formats of energy, which will help in their own right to take the place of fossil fuel, for example. But we do need more out-of-the-box thinking in many ways, and I think that here AI is kind of helping us have the objective view of certain things that we might not realize ourselves, and it's working as a good collaborator for our benefit.
Yeah, as an example, as you brought up the energy domain, there is a lot of research in Finland, for instance, now on photocatalytic hydrogen generation. So you just use the sun and then you get hydrogen and then you store it and then you use it for energy. It's not this simple. There are some catalysts included, but eventually something like this can transform our energy economy totally. If it, you have water everywhere, you have sun everywhere, and if you can make it work really efficiently, then you have solved the energy problem.
Thank you for the good question.
Thank you.
Any other questions at the audience? We can still, after we finish the panel, we can have the questions also one by one, so please stay tuned. But as the time is running, I would like to go for the closing remarks and ask for all the speakers to comment on. There's been a lot of different themes discussed, a lot of good questions where we had interesting points of views taken up. How would you see in the near future the world change to a better place with the use of digital solutions and AI?
Yes, we didn't talk too much about artificial intelligence, but I think that is we are undergoing very dramatic change overall, and this change is as big as when the internet came. So we are experiencing this revolution at the moment, and it's affecting all of us and who are dealing with digital, and everybody who has a phone. I think it's part of this change. So I think that's a really big one that we all need to consider in our personal lives, in our working lives, and I think it's a big challenge both for the public sector and also for the private sector. But I look and embrace this change, because I think it will also bring things that are very good for us and for our lives. Thank you.
To continue there, I'm also a technology optimist myself, and believe almost any technology developed today will be for the better future. But at the same time, understanding really the world where we live in today. When I grew up, I thought, a lot of these societal and human problems would have been sorted out already many times, and we don't have wars and stuff like that anymore. But this is not the case. So I also think myself that we as human beings, we always bear the responsibility for technologies and responsibility for a lot of stuff that technology will never solve. Technology will not ultimately replace human relations, be they at individual level or at societal level. They can complement and support making connections and providing us better services and ways to communicate with each other. But the human connection will never be replaced by technology. That's my own belief, and that's the way I'm going to live at least the rest of my life.
Those were two really big ideas. I don't know if I can match with that. But let's put it this way. The 3D world that we are living in is going to be cyber-physical world also in the digital world. And we can start to actuate things from the digital world. That, for instance, we can start you just download an app and then you start your, different kind of things you can have affecting the world just by using the digital copy of your, for instance, your home or your car or whatever. So these kind of things will come and help our lives, but not for all of us.
Well, being an optimist and also being somehow involved in technology, so I see digitalization as a good tool for many things. So that means that we can use them for the benefit of energy consumption reduction. We can use it for benefit for our environment in that sense. And we can even, when developing tools enough, we can even use them to really improve the social interaction. As Mikko was saying, it doesn't replace face-to-face meetings as we have it here in Osaka now. But when improved, it can somewhat be better than today. But at the same time, we must remember that technology will and can't be the host.
So we have had just interesting few years with all the development, and I think that the evolution of a digital world will be even faster and faster, and we will have interesting times ahead of us. And at the same time, we have a lot of responsibility to make it a good society for everyone, while taking the best out of the new solutions and creating something positive for the whole world. I thank you for participating with us tonight in Osaka, and hope to be able to change some good ideas also with you after this. Thank you. どうもありがとうございました。